Today's lesson is 6.6, Find segment lengths in circles. Our first theorem for today is the segments of chords theorem. If two chords intersect in the interior of a circle, then the product of the lengths of the segment of one chord is equal to the product of the lengths of the segments of the other chord. Let's go ahead and take a look at our picture. What this theorem basically says is that the product of EA times EB, because they make up the first chord, we go ahead and add EB, is equal to the product of EC, let me change my color, there we go, times ED, because they make up the second chord. So take a look at my two chords, my pink and my blue. There we go. What I'm going to do is I'm just going to go ahead and I'm going to break them into two pieces, not necessarily half. And the products of each piece, I just multiply the pieces of the pink, and they are equal to the two pieces of the blue one multiplied by each other. Let's go ahead and give this a try. Find the lengths of chords ML and JK. So first we need to go ahead and find X. And I'm going to go ahead and I'm just going to highlight the pieces of my two chords. So there's a piece and there's a piece. And there's the pink piece and the pink piece. I'm going to go ahead and I'm just going to set it up. I'm going to multiply JK. I'm going to multiply JK, which is my blue. I guess I could write it for you guys. There we go. Is equal to the length of ML. Oops, let's change our color. There we go, of ML. So what we're going to do is we're going to apply the theorem, and we're going to go ahead and we're going to break it into the two pieces. So X plus 5 times X makes up the blue piece of JK, and X plus 3 times X plus 1 makes up the pink piece of ML. I'm going to go ahead and I'm going to multiply next. Now, for JK's side, for the blue side, all I need to do is distribute. And I'm going to bring in my light gray marker here. There we go. I'm just going to go ahead and distribute. And we would typically see the X times X or X squared term first, and then we would see the 5 times X or the 5X term second. For the second one, for the ML side, where it's in pink, what I'd have to do here is I have to double distribute. So X times X, X times 1. 3 times X, here's the double distributing, and 3 times 1. Sometimes you hear it called FOIL, first, outer, inner, last. But basically what we're doing is we're double distributing. We're first distributing the X, and then we're distributing the 3 to everybody. 1X plus 3X would become 4X. I went ahead and these two are like terms, so I can add them together because they are positive, plus 3. Now what I'm going to do is I'm going to go ahead and I'm going to solve this equation, right? Because that's what this is. It's just an equation, and I can solve it. So the first thing I want to do is I want to get everything together. I'm going to go ahead and start by subtracting this x squared and bringing it over to the left-hand side. But what I notice is it cancels on both sides. Now that's actually going to make it easier for us to solve, because it's leaving us with this equation. Once I move the x squared, it leaves me with this equation. So I would move the 4x over with the 8x, which would give me 1x or just x, and I already know that x is equal to 3. X is equal to 3. So let's go ahead and put that right here on the answer blank. And then all we have to do is substitute it back in. Substitute it back in. So to find ML, I have to substitute into this, right? I have to substitute into this. Well, I need to be careful. That's not quite true. Let's go ahead and put up here ML. ML is x plus 3 plus x plus 1. So it's going to be 3 plus 3 plus 3 plus 1. 3 plus 3 is 6. 3 plus 1 is 4. 6 plus 4 is 10. ML is 10. Let's go ahead and do JK. Where do I have room for JK? Oh, right down here. Let's see. Right down here is JK. JK is x plus 5 plus x. X was 3, so 3 plus 5 plus 3. 3 plus 5 is 8. 8 plus 3 is 11. JK is 11. All right, let's look at our next theorem. Our next theorem is the segments of secants theorem. If two secants share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. All right, that's a lot of stuff. Let's go ahead and take a look at it, and let's use our highlighter to help us out. So EA is right here. What this theorem is saying is if I multiply EA times the whole secant of EB, I multiply it times EB, then it is equal to the other secant, the segment EC, that's the external part that they keep talking about, times the whole secant of ED. Okay, so same idea, the outside part times the whole thing is equal to the outside part times the whole thing, secant to secant. All right, let's take a look at an example. Find the value of x. And I've gone ahead and given you a hint here. PR and TR are secant lines. Okay, so I'm going to go ahead and I'm going to highlight this just like my theorem up above. So I'm going to highlight the exterior part and then I'm going to highlight the whole thing. I'm going to highlight the exterior part and then the whole thing. All right, to find the whole part from P to R, I'm going to go ahead and I'm going to add the pieces together. So I'm just going to take these two pieces and I'm going to add them together. 4 plus 6 equals 10. So P to R is going to give me 10. And that if I'm following my formula, I have RQ times RP or PR. That was for the pink side. Let me go ahead and put those are the two pink ones. And then for the other one, I have RS times RT. Now take a look at RT. I'm going to do X plus 5, just like I did 4 plus 6, but I don't know X yet, so I can't say that that equals 10 like I did up above. Okay, I can't say that like I did up above. And then there's my blue side, okay? All right, let's go ahead and just plug in. So RQ is 6 times RP, we said was 10. RS is 5 times RT, which we said is X plus 5. 6 times 10 is 60. And on this other side, we're going to go ahead and we're going to distribute the 5. So 5 times X and 5 times 5. We're going to put a plus in between because that's what we see inside the parentheses. That's what we see inside the parentheses. This is just an equation that I can solve. I can now solve this equation. Here we go. Minus 25 from both sides. 60 minus 25 would give me 35. And I'm going to divide both sides by 5. There we go. X equals There we go, 7. Let me go back up and look. Yep, that's all we wanted. Find the value of x. All right, let's take a look at our next theorem, which is the segments of secants and tangents theorem. Whew, these theorems. If a secant segment and a tangent segment share an endpoint outside a circle, there's my 2, right? The secant segment would be this one, and the tangent would be that one. Then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. All right, so let's take a look and let's use our highlighters to help us out. EA squared. EA is my tangent. EA is my tangent segment. So this is my tangent segment. And what I'm going to do is I'm going to square it, or I'm basically going to multiply it by itself. I'm going to do EA times EA, right? Because that's what squaring it means. Oops, that's what this means. What I'm going to do to the secant segment, what I'm going to do to the secant segment is what we've been doing to the other ones. I'm going to take this external piece, EC, and I'm going to multiply it by the whole secant. Okay, so on the other side, I'm going to have EC times ED. Okay, let's go ahead and take a look at an example. Find the value of x. If RQ is a tangent, take a look at the picture. RQ is my tangent. So I'm going to go ahead and I'm going to highlight it in pink. And I'm going to highlight it twice in pink with just a little bit of space in between. And my theorem says I'm going to take that. I should have made my highlighter thicker. And I'm going to square it. So I'm going to take RQ and I'm going to square it. That's what the theorem is telling me. The other side, and RT is my secant. And I know it's my secant because it's going inside of my circle. And I'm just going to go ahead and I'm going to highlight it like we did up above. And so I'm going to go ahead and put my blue. And what I'm going to do is I'm going to multiply RS times RT. That is what the theorem is telling me to do. So let's go back and let's look at our colors because the pink is 14. So I'm going to do 14 squared. It shouldn't be negative, so it's not going to be an issue if you put it in parentheses or not. But just for next year, when you go into Algebra 2, it's always a good idea when you're squaring a number to put it inside parentheses, because when it is negative, you have to do the negative times the negative, okay? And then here I'm going to do x times x plus 12. Remember, for the whole thing, I have to add it together. So it's going to be the x plus the 12, right? Because RT is RS plus ST. All right, 14 times 14 is 196. And if I distribute my x, I get x squared plus 12x. All right, now I'm going to go ahead and I'm going to take a look at my equal sign. There it is. I probably didn't have to draw it so long. In fact, let me bring it back up. Because if I quick look at it, I don't have what we did earlier in the first example where I got rid of that pesky x squared. What I have to do here is I have to move the 196 over to this side. It is not going to combine with the x squared or the 12x because it does not have an x at all. It is its own separate term, and I'm going to have to set this equal to 0. Now, I have a quadratic equation that is in the form ax squared plus bx plus c. I can go ahead and I can identify my a, my b, and my C. Here is my A. It's going to be the 1 right there. Here is my B. It's going to be positive 12. And here is my C. It's going to be negative 196. Okay, there's my A, my B, and my C. Now my next option is I can try to factor this. I can try to factor this, but it may not be factorable. So one of the things we learn in algebra is to solve a quadratic by using the quadratic formula, which is negative b plus or minus the square root b squared minus 4ac all over 2a. I would suggest you guys just go straight to the quadratic formula and don't even try to factor, okay? 196 is a big number. It has a lot of factors, and none of them may equal to 12. None of them may equal to 12. So let's go ahead and let's just go right into the quadratic formula. And I'm going to go ahead, take a look. I'm going to help myself out here by coloring in my letters, because that's going to help me to substitute faster. So I like to, whenever I have a formula like the quadratic formula or any of the theorems, I like to use a skeleton. And this formula in particular leans itself to a skeleton very nicely. So a skeleton, just like the skeleton in your body, is just the support structure. Okay, and what we're going to plug in each of those in each one of those parentheses, the A, the B, and the C are going to be like our organs, right? They're going to help us out. So I can very simply see that my A's go here in the bottom and here right after the 4, right? I'm just using my color from over here. I can also see that my B's go here and here. And this last one is for my C. So let me go ahead and plug that in. Almost didn't have enough space. There we go. Now you want to be careful because you want to go ahead and do as much multiplying as you can, okay, before you actually go to the calculator. Negative 12, this first one right here, you just have to decide, does it stay negative or does it become positive? And it's going to stay negative. And then what we're going to do is we're going to go into our calculator and we're going to put just this part that I'm circling. So we're going to put 12 squared minus 4 parentheses 1 parentheses negative 196. We're going to put that all in and we're going to get 928. And on the bottom we have 2 times 1, 2. Now, what actually happens here is we have two distinct answers. This plus and this minus say that we need to split our problem. We're now going to have to split our problem into 2. And in the calculator, we're going to put negative 12 plus the square root of 928. I don't know if it's a whole number or not. And then we're going to put negative 12 minus the square root of 928 divided by 2. Okay, so I have to go ahead and split it, and I have to split it into my 2 separate answers. When I put this one in, this one comes out to 9.23 when I round, and this one comes out to negative 21.23. Well, I know that I cannot have a negative distance, right? This piece of this segment cannot be negative. That makes no sense because think about it in your real life. If you were to make this figure, you were making this for me out of anything, any type of material, wood or straws or spaghetti. Could you measure me a negative 21.23 centimeter piece of some kind of material? No, you can't. You cannot measure a negative piece. It doesn't make any sense. So this is not an answer that we would use in geometry because we're tying it to that shape. And this would be our final answer. Okay. All right, we have one last thing to talk about today, and that is arc length. Arc length is a portion of the circumference of my circle. So we've talked about how to find the degree of this arc from A to B, but we've never talked about how to find its length. How long is that purple piece of the circle? How long is this piece? To do so, I use this formula. I'm going to take the central angle and I'm going to divide it by 360. And then it's going to set it equal to the arc length divided by the circumference formula, which is 2 times pi times the radius. 2 times pi times the radius. Now, I prefer the pi key, but if you can use 3.14. You can use 3.14. That's a very common decimal for pi. Okay? And we're going to go ahead and we're just going to try one. Here we go. Find the length of the red arc, round to the nearest hundredth. So my formula says I'm going to take my central angle, which is 60 degrees, and I'm going to divide it by 360. What I want to show you is that both of these numbers should have a degree symbol with them. If you are not putting the degree over the degree, you are setting up the arc length problem incorrectly. Now they are asking me to find the arc length, right? They said right here, find the length of the red arc. So this is what I want to know. So it is okay to go ahead and to just call it X. And for this other one, I'm going to go ahead and put 2 times pi times my radius, which is 8 centimeters. I went ahead and put it in blue just like I did in the formula just to help you out. I'm going to go ahead and I'm going to cross multiply. So I'm going to multiply 360 times x. And then I'm going to multiply 60 times 2. 60 times, oops, no, I didn't want to do that. Hold on, guys. Sorry. I wanted to keep with my color. It's 2 times pi times 8. Now what I'm going to do next is I'm just going to show you that you can write this teal side. You can just multiply all the numbers. So you could do 60 times 2, 120, 120 times 8, 960 pi. Okay, sometimes you get asked to leave your answer in terms of pi, and this is what they're talking about. Okay, we're going to divide both sides by 360. And yes, we're going to go into our calculator and we're going to do 960 times pi. And it's your choice if you want to use 3.14 or the pi key. And then divide it by 360. And we end up with a decimal. But they're going to ask you to round. We're going to be asked to round. And if we round to the nearest hundredth, remember 100 has 2 decimal places, so I count 2 after. There it is. The third one is going to tell me if I should round or not, and the rest of these numbers in my calculator do not matter. So this number is going to decide, should I keep it 37 or should I make it 38? Since it is 5 or more, I'm going to say my answer is 8.38 centimeters, about. Okay? All right. See you guys next time.